Let's begin with an introduction for myself. My name is Raosaam SB Sharaheel and I'm the SAT math tutor for Titans Education. I currently study at Davidson College in North Carolina. I'm a double major in economics and computer science here. And I guess you could almost say that I specialize in standardized tests. I scored 1500 plus the time I took SAT with a perfect score in math. Immediately after that, I took the ACT and I scored a 34 out of 36 with a perfect score, ironically, in reading and writing that time because I'd practiced for it a whole lot more. And I also ranked second on the national merit list for IB admissions when I took the exam for it a couple of years ago. And I think a lot of that can be attributed to how much I've studied the process of standardized tests in general. And I really hope that my expertise in that field can be helpful for anybody who chooses to enroll in this course or follow along with my videos. With all of that said and done, with the introductions out of the way, let's talk about SAT math. Let's talk about its structure, what kind of content it covers, and how we can do better on the SAT math. So the first thing I'd like to talk about is the general structure of the SAT math. If you guys have already looked at what the SAT looks like, you know there are four portions to it. First there's reading, and then there's writing. And after you've already spent a significant amount of time concentrating really hard on getting all of those questions right, when you're already exhausted of sorts, the second half of SAT hits you. It's SAT math. So the first struggle in dealing with that structure is that you need a whole lot of stamina to have the energy to continue or to power through SAT math. And it's all about precision, right? Because when you're exhausted from having worked so hard already, you tend to slip up. You lose 1 or 2 points. You make tiny mistakes you wouldn't have made otherwise. So that's one thing we need to know about the SAT. It's long, and the second half of it is SAT math. But even then, SAT math is divided into two portions. First, you have a calculator segment where you have to answer 38 questions in 55 minutes. So these questions are a little more complex in terms of calculations, which is why they give you a calculator. You have the option to use it. But often it can also be easy, and calculators can be deceptive because you feel like there is a need for you to use the calculator, yet you could save a lot of time if you just didn't use it at all. If you relied on the options they give you or used common sense and your general understanding of math. But after that, there is another segment, which is the no calculator segment, and that's 20 questions answered in 25 minutes. And that's all about precision and speed. You have to solve it as fast as possible so that you don't struggle for time in that segment. So the general principle for the SAT is that it's all multiple choice. Once you take the reading and writing, all of the questions there are just circling in bubbles from the choices that are given to you. The only time you'll see an exception for that is in math, where most of the questions are indeed multiple choice, but roughly 20% of the questions are gridded answers. And we'll talk about that in detail later. But for now, what it means is that in those circumstances, you won't have choices to select from. You have to grid in answers on a blank bubble. So you don't get to just pick and choose and hope that you get it right. And even in all of these things, in math itself, they have three different categories of questions they ask you. And the next portion of this video will take each of those segments and try and break it down for you guys. So they have very fancy names for it because College Board administers this exam. They have fancy names like the Heart of Algebra or Passport to Advanced Mathematics, which essentially is jargon for much simpler things. The SAT exam is a standardized test, right? So the cool thing there is that the objective of the exam is not to stump you. They're not going to give you questions that are way beyond your level. It's all content that's already been covered in high school. So it aims to check whether you're ready for college or not. So anybody who's appeared and paid a decent amount of attention in what happens in high school, by the end of their high school lives, will have a decent idea of what all of these three categories are. And let's try and break it down even further and talk about essentially those key focuses of the SAT math and how we can do well on each of those segments. Ideally, I'd like to give in-depth analysis of all of the content that's covered, but because of the nature of like what math is and how individual problems differ from another, I can only take excerpts from what each of those questions might look like and give you guys a taste of what my teaching or what my method for solving all of them are. I hope that inspires you or at least gives you understanding of how better to go about each of these categories of questions. Let's dive in. So the first segment that I want to discuss is the heart of algebra, which is fancy jargon for anything that involves variables. So the creation or the manipulation of algebraic equations where you're not given hard numbers, but variables like x and y to replace those numbers. Anything that involves algebraic equations or systems of equations where you have multiple algebraic equations given to you and you can ascertain information from the relationship between those equations, real-world applications through either word problems or just completely theoretical algebra. All of that is included in the heart of algebra. And I guess it also has analyzing graphs of equations on a Cartesian plane. So looking at graphs, lines, and being able to understand what all of that represent, what it means, and being able to manipulate the data given there to reach conclusions, all of that is included in the heart of algebra. And from that explanation, I guess it's fairly clear that this isn't something that we're new to. If you've been through high school, you've already spent multiple years working with this. So somebody who didn't prepare at all for the SAT, somebody who paid attention in high school, should already be on some level capable of solving some of the questions that appear on Heart of Algebra, as is true for almost anything that appears on the SAT. What we'll try and do right now is I'll give you a question as a sample from the Heart of Algebra, and we'll try and solve it together. The question you have on screen right now is a fairly standard question for the SAT. So what I'll do right here is I'll pause and I'll give you an option if you want to try and solve this question yourself. These are the choices that are available for you. I'll wait here. You can go ahead and try and solve it yourself. Pause the video, go ahead and just give it a try. So assuming that either A, you've tried solving this yourself, or B, you just want to enjoy the show, you want to tag along with me and see how I solve it, let's begin that right now. I'll try and read the question out for you, and I'll also walk you through what's going on in my mind, how I'd go about trying to solving this. So first, let's read. The graph of the line K is shown in the xy plane above. Which of the following is an equation for a line that is perpendicular to line K? Okay, so I have the x-axis given to me here, I have a y-axis given to me, and there's an extra line there, and I assume that's line K. The first thing I try and notice here, I wouldn't even look at the choices, which is why I took that off the screen. I don't want to look at the answers right now. I don't want to cloud my mind. All I want is to understand what the question is asking from me. It's asking for an equation of a line that is perpendicular to line K. So the first mistake somebody is likely to make there is, instead of taking the equation for the line K, instead of taking the line that is perpendicular to it, they might just take the equation for line K and think that they have their answer. So we want to be very careful to avoid that pitfall. I'll give myself the choices now. And the moment I look at these choices, I already know how I want to try and solve this question. Because, well, I guess the cool thing about SAT math is that because it's a standardized test, all of this stuff, it's not meant to be crazy difficult, right? Which means, especially in the heart of algebra, there are multiple ways of trying solving this question. I can already think of 3 ways to solve it, and there might be more. The thing about the SAT is that it's all about precision. It's meant to distinguish how qualified you are to go into college right now. Which means between these 3 ways of solving it, there are distinctions. One of them is faster, and some people do one better, and the entire point of the SAT is being able to choose the best and quickest method of solving these questions for you. So when I look at this choice, there is automatically one thing that becomes very clear to me. I won't even try and solve the question now. We'll try and reason through it with the most basic of mathematics sense. this graph, the line K, is downward sloping. So from left to right, it's headed downwards. And if I were to draw any line perpendicular to it, any line that is perpendicular to a line would essentially have to be upward sloping. From left to right, it would have to be on the rise. So I guess you're seeing a mirrored image of what I'm trying to show. So line K would look like this to you, and any line perpendicular to it would have to be like this, bending upwards. And all of the choices that are given to me are given in the format y equals mx plus c, where the coefficient of x, m, denotes the curve of the slope, and c is a constant. So I know just from looking at this figure that if I want a perpendicular line to k, its slope has to be positive. And I can just look at choices A and B. The coefficient for x are -2 and -1/2, and both of them are negative. So I can just take one look at the question. I'm certain right away that A and B are never going to be my answer. My choice is between C and D. And this is a process that takes less than 10 seconds for me. So we can look at choices A and B, list them out immediately. We're left with two choices. And on our worst day, if we close our eyes and guess, we still have a 50% probability of getting it right, which is fairly straightforward. But we can bend that probability even further in our favor, because there are more inferences to be made from just looking at this image that helps us get to the bottom of this answer. I have two slopes here. For choice C, I have half x, so the slope is half. And for y equals 2x on D, the slope is 2. And when I think about a line perpendicular to another, I can see that the intercept for k is higher on the y-axis than it is further from the origin on the x-axis. So it's a steep line. And the steeper my line is, the line perpendicular to it is that much flatter. So because k is steep, it makes sense, it is more likely that whatever line is perpendicular to it would tend to be more flat. So between the choices y equals half x plus 3 or y equals 2x plus 4, I'm already inclined to choose half of x plus 3, which is option C. And I'm not absolutely sure that's the correct answer, but all reasonable conclusions and justifications point to C being the right answer. And this entire process would have, on exam day, taken me about 20 seconds. So the fastest way to solve this problem would have been inferences, trying to make most of our knowledge of graphs, of slopes, of equations for algebra, of straight lines for on graphs. But now that we already have a preferred choice in mind, let's try and verify whether that's the correct answer. There are other ways of solving this. Let's try work through those, and I hope when we get to the end of this, our answer will have been correct. So instead of wasting a lot of time theoretically solving this, we could take one look at this. We know it's already the right answer, and it's very easy for us. It saves us a lot of time. So I hope my notepad is visible on the screen for you guys. Let's brainstorm how we want to solve this, because like I've said, there are multiple ways of solving this, right? I think the most theoretical way of trying to solve it, the purest way of trying to solve it, would involve knowledge of equations, of straight lines and how they're drawn on graphs. So if you weren't given any choices at all, in order to theoretically solve it, first we'd have to find out the equation for k. Then we'd have to use our knowledge of slopes to find out the value of a slope perpendicular to that straight line. And then we'd have a general formula, a structure. We wouldn't have a straight line because we wouldn't know what the intercept is, but we'd know for certain what its slope is. And we could use that to compare it to choice C and D and find out which of our answers fit, and that would be our answer. Just because it's the purest or most theoretical way of solving it doesn't mean it's the best way of solving it. Sure, if you were given no choices at all, this would be the cleanest or most surefire way of solving it. So it's the one that denotes complete mastery of the subject. But we are given choices on the SAT, and it makes no sense to ignore the fact that we are given that. So we can use our information here and we can try solving it another method. By the end of this, all we want to do is have our answer. We need to be sure whether it's C or D, and as long as we can do that, we are satisfied, we are happy. So let's try that. What I want to try solving this through is by drawing the straight lines for these two equations and seeing which one is perpendicular just by eyeballing it. So first let's draw K. I can look at this graph and it tells me that for the line K, I am 6 intercepts up on the y-axis and 3 intercepts down for the x-axis. So let's count 1, 2, 3, 4, 5, 6. 6, that's up. Oh boy. Sorry about that. It's 1, 2, 3, 4, 5, 6 up here. 1, 2, 3 here. If I join these 2 points, I have my K. So from this format over here, y equals mx plus c, I can draw any straight line that I want. Here, the c, the 4, indicates an intercept. So if the value for x were 0, meaning if we were on the x-axis, where that straight line would pass through the x-axis is what this intercept denotes. And this is my slope, which is commonly denoted as rise over run. So for every 1 block I go to the right, how many blocks I am going up. So in this case for D, for every 1 block that I'm going to the right, 2 blocks that I head up. And if I were to try and draw this, my intercept is 4, that would be 1, 2, 3, 4 over here. This is where my intercept on the y-axis is, and my slope says these are the points it will pass through. I go 1 block to the right, 2 blocks up, 1 block to the right, 2 blocks up. And if I connect those 2 points, this is what line D looks like. And I can take one look at this and I already know that that does not look perpendicular to me. It's quite obviously not. And that's good enough because I have ruled out choice A, I have ruled out choice B, I have ruled out choice D, and I'm already left with my answer. But for the purpose of this video and for the ease of mind, if we wanted to be absolutely sure that C is the answer, we could draw that as well. Its intercept is 3. So 1, 2, 3. And its slope is half, meaning for every 1 block to the right, I go half block up. And if I were to multiply both of these values times 2, that would mean for every 2 blocks, I go to the right, 1 block up is the general direction. So 2 blocks to the right would mean from here, we go up to here, and 1 block up. 2 blocks to the right, and 1 block up. And if I connect these 2 points, that is line C. And this already looks like it's perpendicular to me. And I have tried solving it in 2 different ways. First just by eyeballing it and then drawing it out. If I were to do it in an exam hall, I'd try and draw this as well to scale as I can somewhere in the corner of my question sheet. And if I had drawn it appropriately to scale, I would already have my answer. And the answer is choice C. So there you have it. That's what the heart of algebra looks like. And in our lecture, we'll break it up into modules, discuss a lot more in detail about all of this. But from what we've discussed so far, I guess it's fairly certain, it's clear that it's all about being able to understand things from graphs. Unless we knew how to draw straight lines from just equations, we wouldn't have been able to do this. Unless we knew what the slope meant, how it uh, relates to the graph that we're seeing, to these lines, we wouldn't have been able to solve this. And mastery of any of these things takes us one step closer to being able to solve heart of algebra fluently. We'll discuss more about this later, but for now, let's move on to the next segment. So the next segment of the SAT is problem solving and data analysis. And what it deals with is essentially real world problems. This is the segment where you'll see the most number of word problems, where they try and contextualize it for you. So there's a lot of reading involved. You are given almost like passages with a lot of information, and you have to filter out all of the things that are unimportant, find out just the kind of data you need from a story they tell you or real world scenarios they give you, and use that to solve a problem, reach a conclusion, get your answers. So because that's how it's structured, they essentially use a lot of concepts that are very relevant in the real world: ratios, percentages, proportions. And beyond that, the one thing that is a little theoretical is how they ask you to analyze graphs and tables using statistics data, or stuff you've learned in your statistics classes, that portion of math in particular. So we'll talk about this in detail later, but right now there's just one example I want to give you of what this segment might include and what kind of knowledge you need to answer it. So we'll try the same drill as last time. You have the question in front of you. I'm going to give you the choices as well. You can choose to pause the video here now, try and solve it yourself. I'll give you a little time for that. Assuming you've either solved it yourself or you want to watch along with how I solve it, let's begin now. If you've already read this question, the one thing you'd notice that makes it different from what we've done previously is that it's a lot more knowledge based, right? For what we did for the heart of algebra was about your speed of calculation, how you can manipulate data, what tricks and stuff you use. When it comes to problem solving and data analysis, that's not the case. It's a lot more about how much you know. Knowledge is what helps here. You need to understand statistic concepts to get them right. So let's look at this question. Reading it out loud, the dot plots above summarize the scores of two classes, each with 24 students at Central High School. The name of the school is not important for me. This is a quiz, so the quiz is ranked from 0 to 5. Which of the following correctly compares the standard deviation of the scores in each of these classes? Brilliant. So the first thing we notice is that the concept of standard deviation is very important for us here. If somebody knew nothing about standard deviation, they probably wouldn't be able to solve this question unless they tried using a calculator. I'm sure this is a question that would appear in the calculator segment of the question, and you could do it the hard way. You could punch all of these values into your calculator, use the function for standard deviation you have, do it for class A, do it for class B. You'll have two concrete numbers. They'll give you a number which represents class A standard deviation. You'll have a number for class B's deviation. That would take a lot of time because there are 24 different values you have to punch in. No matter how you try and shorten it, that takes a lot of time. So that's for somebody who didn't understand how the concept of standard deviation works. But if you know the definition for standard deviation from its formula, essentially it's taking an average, a mean, and comparing each data point, how far it is from the data point. Summation of the squares of all of those over essentially the number of data points give you some measure of standard deviation. So we can break all of that up. A lot of that is constant for a lot of things. But between class A and class B, what differs is the average and how far each of the values are from the average. When I look at class A, the average or the mean value is somewhere between 3 or 4 because those stacks are so much taller. For class B, it would be perfectly spaced between 2 and 3, it'd be 2.5. But when we try and find the difference of each data point from your average, they'd be very far spaced apart because it's all evenly spaced. There are as much values of students scoring 0 as there are 5. But for class A, it's clustered together, so that value would be less. When I plug it into the formula, it would essentially give me a lower value because all of those differences would be less. Just from that knowledge of how standard deviation works, I can look at this question once and in a span of 15 seconds, I can tell that the standard deviation of scores in class A is smaller. For the average layman, if somebody didn't know how standard deviation works and they didn't even know how to punch it into a calculator, they would feel like image B, class B, is much more stable, it's well balanced, so you'd feel you're inclined to answer that the standard deviation there is less, which is wrong. So from there we understand how SAT filters out different levels of understanding, and it's the same everywhere, maybe not on this level, but the better you understand ratios or percentages, the better you can filter information, the better you can answer problem solving and data analysis questions. Here you wouldn't even need to pull out pen and paper. You could if you wanted. I don't really see why you would, but you could, and then you can just use a calculator, solve it. That takes a lot of time. You'll get to the answer, but you'll have wasted a lot of time. Or you can use your knowledge of standard deviation, find the answer straight away, circle it in with confidence, and move on. And that's about it for problem solving and data analysis. We'll move on to the next segment, and in my future classes, we'll take every concept that can appear on data analysis, especially the statistics portions. We'll teach all the formulas, and I hope that'll help you in the future. So, passport to advanced math. This, in my opinion, is the most theoretical aspect of the SAT math, because the concepts that are taught in passport to advanced math, well, it's named so because these are math that you will need if you want to pursue sciences in college. So quadratic equations, you wouldn't see applications for those in real world mostly. You'd have to use them for modeling, modeling curves, modeling real world occurrences in a statistics lab, or for higher sciences, sociology sciences, all of that. So anything that deals with quadratic equations, polynomials, functions, things that are more or less conceptual math with less application in your everyday life are things that you'll see in passport to advanced math, which is why I feel like this is where people falter the most. This is where you have to understand math in order to excel. So just to exemplify how that works, I tried finding an example here. So this is the question I have for you, and I'll give you your choices. Please feel free to pause the video, try and solve this for yourself if you want. Given you have already either tried solving this or want to solve it with me, let's begin now. You'll see here that I didn't even feel the need to have all of the choices included. I didn't even show choice D. And that's because here choices are almost irrelevant. Let's read this question out. So the function f of x equals a tough equation, a polynomial. It's fancy. It's grabbed in the xy plane as shown above, and k is a constant here, such that f of x equals k has 4 solutions. Which of the following could be the value of k? Okay, if I wanted to solve this, I could find k, but that's a hard and long-winded way of trying to go about this. The graph is given to me for a reason, and here you have to make a judgment call. How do you want to solve this? If you wanted to solve it using equations, you can write f of x out, you can replace that value with k, you can try and isolate k, find its value, and find solutions like that. And you could see for which value of k there are 4 solutions, because for each input for k you might have a different number of solutions. That's how this variable equation works. But you don't need to do all of that because you have a figure given very clearly to you. And if we knew how functions work, here it's for every value of x, for every input you have for x, you get a corresponding value on f of x, which is the value of the function. So we are to look for an f of x value or some point on the y-axis where for one input of x, you have 4 values on the y-axis. So in terms of a graph, that would mean an x-axis point or one slice from the x-axis where this line, not straight line that is given to us, intersects or crosses that one level in 4 different places. So if we were to look at this and look at the choices, let's start with B and then let's start with A and work our way down. When the value of x is A, what is the value of f of x? We have 2 possible answers when we're looking at this graph. When x is 1, one value is close to -2 and the other is close to 2. When it's 0, there are still 2 values possible for me. When the answer is -1, when I input a -1 on the function, on this graph what I see is that it crosses over in 4 different places. First on the leg down, then again on the up, and the mirror image on the other side. So this figure, just looking at it once, when I look at that straight line that represents x equals -1, I know it crosses over 4 times. There are 4 possible values. That value can be something a little less than -1, it can be 0, it can be a little more than 1, and it can cross over in all of those places. So that understanding means that I don't even have to look at this equation and try and solve it by hand. This graph tells me it intersects in 4 different places. That's good enough for me. My answer is -1. If I circled in C, I'd get it correct. But this exemplifies how much you know about a concept makes a difference in how you try and solve it. The better you know, the more likely you're going to select the easiest way to solve a question, get it down straight away, move on, and you won't even have to worry about it. So what do people struggle with on the SAT? As I've already mentioned, almost anybody given an infinite amount of time, anybody who's gone through high school can answer the questions that appear on the SAT. But you're not given an infinite amount of time, and that pressure leads us to make mistakes. So even easy things become just a tiny bit more difficult. And when you're answering a total of 80 questions, 55 with a calculator and 25 without, of those 80 questions, you are bound to get a couple wrong. And each one you get wrong decreases your marks by a tangible amount. And that's what makes the difference between people in SAT. So let's talk about the things people struggle with. The first thing is that as a standardized test, the questions are designed in a way where the choices will appeal to you. So if you tried answering a question and you made a tiny mistake, you're still likely to end up with an answer that you see on one of those choices, and that gives people a sense of comfort. They don't feel the need to double check it. Since you already have your answer on the multiple choice sheet, you circle it in and you get the wrong answer. This is the way College Board designs it. They don't make the questions difficult, but they make you comfortable with the wrong answers. They know what kind of mistakes people can make, and they build the questions around that. The second mistake people make is in time management, because it's in essence an exam that somebody can finish really quickly. The 25-minute portion of the SAT I finished in less than 10 minutes. I had 15 minutes left. And time management does not always come easily to us, because when you're on the edge of getting a question right, you feel like you pursuing through it. When there is a question which is not difficult and there are multiple ways to do it, people often settle for taking as long as they need to finish it because they know they can score points on this. What they don't recognize is that they're not prioritizing right here. So the third issue is also related to this. because they don't prioritize, because they don't manage their time in that process, they get fixated on a question and they let the chance to answer other questions which are worth just the same amount of points pass them by. That's what I mean by prioritization here. Just because you feel like you're closer to answering a question doesn't mean you get valued more for answering that question. All of the answers on the SAT are worth equal. And this one thing that the SAT makers do is that they vary the difficulty for questions a little bit. There are some that are terribly easy. You can answer them in less than 20 seconds, but they're on the end of the exam sheet. And if you go serially and you get fixated on a question, you may not have the time to finish answering that last one. And it could have potentially gotten you the same amount of point that you get fixated on another question for in significantly less amount of time. They design it so that all of the questions you should be very easily able to solve in the amount of time given to you, but not all of those questions should take the same amount of time. So a large part of standardized tests in general, not just the SAT, is knowing when to give up on a question, knowing when you're so close that you need to invest time to finish something, and maximizing not just like the answers, but maximizing what you can do to the best of your ability. And regardless of how skilled you are at math, just knowing how to prioritize right, knowing when to invest your time can ensure that you get the chance to answer just a couple of more answers properly. And that can boost your score by 20, 30 points, which could be the difference between getting into the college of your dreams or not. So yes, I kind of have some minor solutions, some quick fixes to these problems that people struggle with. I'll try and give them to you now, but realize that these are just quick fixes. The only way to get perfect scores on math is understanding math. It's practicing math. But like all of that set aside, let's talk about quick fixes for SAT math. So quick fixes. And it's pertinent to mention that we aren't strictly in the field of math when we talk about this. We are discussing the science of standardized tests. Because as much as the SAT says that they are measuring your skill in math, all they're really doing is measuring how skilled you are at taking a math exam. And there are hacks to that. You can get better at taking a math exam without being absolutely proficient in math, which is what I try to do through these quick fixes. The first I want to talk about is the art of guessing, ballpark estimates. And I call it an art because, in a way, it is precisely that. It's something that needs to be perfected over time. When we're solving something like an equation, our tendency is to get to the finish line, to finish the entire thing, and have the answer written out for us, take that answer, look at our choices, and compare. Often, we don't need to do all of that. There are certain things we can leave, well, uncertain, undecided all the way to the end. For example, the first question we were discussing with that straight line K and what it could represent, there are a lot of things we can ballpark. And I hope the lesson we've given there is useful here. Because the first thing I did when I looked at the choices, I was already using two of these techniques. Ballpark estimate was when I isolated it down to choice C and D, and I looked at it and I knew it felt to me that C is more likely to be the answer than D, just because of the nature of how slopes work. I wasn't completely sure at that point that that is the answer, but it's more likely to be the answer based on what I know. And when I'm short on time, when I have more important questions to answer, when I haven't answered all of my questions yet, I could go on that hunch, and if I had answered C there, I would have gotten it correct. This hunch is something that we don't always follow because it feels a lot more comfortable to find out an answer. But a student who makes the judgment call to follow that hunch and save an extra 40 seconds, not drawing anything in to invest in another question, often ends up scoring more. Intuition is also helpful because it works hand in hand with ballpark estimates. The more things you cross out. Not all of the answers of the choices that are given to you feel equally likely to you. You may be confused between two or three. If you can cross out just one option or two options, just from a strict probability sense, you are way closer to solving an answer. So I think that is a very big part of the SAT. They give you those multiple choice for a reason. Cross out as many answers as you can. If you can't find out which one your answer is, cross out which one you are sure isn't the answer, and you're one step closer to just guessing and getting it right. The one quick fix that I haven't already given you guys an example for is reverse engineering. And I guess this is sort of my favorite. And this is one that I'll leave to you guys. I won't do it for you. You can try it out for yourself. I have a question here. Look at the system of equations above where k is a constant. For which value of k is there no solution? So there is one way of theoretically doing it, but we won't try that. Assume you've finally made it to the end of your exam. You have an infinite amount of time. All you need to do is just get this one question right. Instead of solving this, what you could do is you could use each of those choices, plug them in and see if you get an answer. Try and replace the value of k with first -2, then 0, then 2, and see if you get a solution. So they ask you for which of these values is there no solution. And if you try all three of choices A, B, and C, and you can get a solution for this system of equation, you know your answer. For if any of them, you try and use it, you don't get an answer, you also know instantly that that is your answer. So if you tried it with A and you can't find the solution to the system of equation, you don't even have to try the rest. If you manage to find that there is a solution, you move on to the next, and by the time you're done with three of these choices, your answer should be very clear. This shouldn't take an infinite amount of time. If you take just 2 to 3 minutes, you can find the solution for this. Even better if it's on the calculator segment of the exam, you can punch those numbers in less than 30 seconds to your calculator. You have your answer. You don't even have to solve it, and that's how easy it is. Use these techniques. If you use estimates and you use your intuition and you know which is the best thing to do when you solve from the question down or when you solve from the answer up, you can boost your scores on the SAT by a significant number. Regardless of whether you work with us at Titans Education, I wish you all the best. I hope you do really well on the SAT. If you thought this video was helpful for you, if you think my tutelage can help you a little more, please subscribe to our channel, enroll for our courses, and I promise to do the most that I can to try to the best of my ability to make sure that your SAT math at least is something that you're completely happy with. Those scores are things you can be proud of and that can help you get into your dream college. Thank you so much for hanging with me so long. Best of luck for the SAT.